We are constantly told that keeping our camera's ISO setting as low as possible will prevent digital noise. But looking at the physics of the sensor, this is a gross misunderstanding of how cameras actually work. Let's run a real-time experiment to see the effect. Grab your camera, switch it to manual mode, and step into a dimly lit room. Drop your ISO down to 100, the setting usually labeled as clean, and dial in a standard handheld shutter speed. Do not slow down shutter speed to compensate for the darkness. That introduces motion blur, which will corrupt the results of this test. The resulting image is pitch black and unusable. This is the starting point of low-light photography, forcing a choice between two very different methods of brightening the frame. Resist the urge to take the dark photo into editing software, dragging the exposure slider up. To see why that fails, we have to look at the internal environment of the sensor. In a dark room, photons of light are scarce. They strike the camera's sensor irregularly, creating an inherently random distribution of light. The sensor converts sparse physical photons into a weak, fluctuating analog electrical voltage. This weak voltage must be translated into ones and zeros by the analog-to-digital converter. This component is notoriously noisy, injecting its own layer of chaotic digital static directly into the image data. Brightening a low ISO photo on a computer later only magnifies this post-converter corruption. Trying to fix it in post effectively destroys the image quality. Pick the camera back up. This time, scroll the ISO dial up to 1600, 3200, or higher until the exposure meter hits exactly 0. This is the actual function of the ISO setting. It acts as an analog amplifier, boosting the electrical voltage before the signal reaches the digital converter. Since the signal is now stronger, the clean image data dwarfs the static added by the converter. This physical hardware intervention protects the image's integrity from the camera's internal processing flaws. Now, press down the mechanical shutter button and capture the new high ISO image to test the final result. Play back the image on the screen and use the 100% zoom function to inspect the fine details. Directly compared to the low ISO image we brightened in post, this high ISO version is visibly cleaner. The color blotches and heavy static are largely gone. While some natural grain remains because of the scarcity of photons in the room, the high ISO image is the superior file. The photographic data successfully overpowered the digital conversion noise, proving the advantage of using the analog amplifier over digital brightening. This result shows how understanding the sensor's hardware allows for a properly exposed photograph even in difficult lighting. To get the best image quality in low light, a higher ISO setting is the best tool to overcome digital noise. You should now test the limits of your specific camera model in a dark room. Shoot a sequence of photos, systematically scaling from ISO 800 up to ISO 12,800. This exercise will show you the exact point where the noise becomes unusable on your sensor, allowing you to use the ISO dial with confidence.